Welcome to this lesson in which you will learn the basics of capital. We'll do this by understanding how capital addresses industry challenges, doing so by modeling complex electrical systems as a digital twin. We'll cover the core principles that capital adheres to and finish with a few examples of concrete benefits our customers have seen. Let's get started. The key challenge we see as we engage with our customers in all of their various markets is that the complexity of the electrical system is at a tipping point. Companies can no longer rely on the good enough semi-manual methods they've used in the past. They simply won't scale. To give you a sense of the types of complexity we mean, here are a few data points. In the automotive sector, the software that is embedded in the electronic control units around the vehicle requires tens of millions of lines of software code. There are billions, soon to be trillions of electrically unique ways an automobile may be ordered. Since an end customer might choose any combination of optional content, the full complexity of what could be ordered has to be designed, tested, and manufactured ahead of that order. If we look at some aerospace examples, the sheer scale of the electrical system becomes staggering. Hundreds of electronic control units and hundreds of thousands of wires to connect them together. Additionally, the requirements for certifying a product are significant and rely heavily on data of the as designed, as built, and as upgraded being accurate and always available. One capital customer stated, "Complexity is increasing at such a rate that our company can't solve the problems by simply adding more engineers. Tools are needed to transform the design flow to improve design speed and quality for our complex machines." In other words, those semi-manual development methods are inadequate because they simply aren't enough engineers to sustain them. To address this challenge, digitalization of the design processes and assets is required. This is the foundation of a true model-based systems engineering principle. Siemens is the world's #1 supplier of tools supporting the digital enterprise with integrated tools delivering multi-domain model-based systems engineering. Capital is the premier solution for realizing these principles in the electrical systems design space. If we think of the life cycle of a product as 3 key phases, those would be ideation, in which the idea of the product comes into existence, followed by realization, in which the product is produced and becomes a thing in the real world, followed by utilization, in which that product lives the life and performs the role for which it was intended. Feedback of data captured during the utilization of the product can further improve future products and production methods. For a model-based systems engineering approach, which is required to solve the complexity of these products, we must include a digital twin that captures the realities of each stage in the life cycle. In other words, we need a digital representation in the ideation stage that captures the mechanical and electrical aspects of that product. The twin must also be informed of how it will be produced and ultimately utilized once in the field. Capital is the product in which the electrical aspects of the digital twin are described and generated. What you're seeing here are 3 tools within the suite that highlight the product twin, the production twin, and the usage twin. And this is true of any product, whether it has wheels, wings, or never even moves. You might be asking why. Why is the digital twin so important? Digitalization enables us to provide significant automation of the mundane, key optimization capabilities, simulation and verification, maximum reuse of intellectual property and assets, repurposing of existing assets for different usage, traceability and sharing, and so on. The real benefits are in reduced errors and lowered risk, better designs, lower development and production costs, shorter cycle times, more innovation, and so on. In short, it enables the organization to scale their capabilities exponentially without the need to scale headcount at the same rate. Capital is a suite of tools targeted at specific types of activities and users. We divide these into 4 primary categories. The defined domain is first, and is where functional designs can be deployed to platform architectures to explore proposals and understand the impacts of decisions across the network, hardware, software, and wiring design spaces, so that truly informed and balanced decisions can be made. The design domain can consume outputs from the previous defined domain to create physical wiring designs. Electrical designs can be applied to physical topologies, typically from MCAD, to constrain this design work. Depending upon the needs, the wiring design assets may be created interactively or synthesized automatically. The define and design domains map to the ideation aspects of the digital twin. On the right, the produce domain is where products are realized. Sophisticated automation is applied to the harness designs from the design domain, such that bills of process, work instructions, line balancing, and so on can be automatically generated for the harness manufacturing plant. The maintain domain allows our customers to provide support for their products once they're being utilized. Highly automated tools can repurpose the existing as designed and as built data available to create for-purpose technical documentation. This could include service schematics and documentation regarding diagnostic procedures. A variety of output formats ranging from PDF to hosted smart web clients are available depending upon the service organization's needs. In the center and underpinning all is a sophisticated data management system in which all design assets are maintained. It includes tools that enable process control, user control, change management, and so on. This managed domain also encompasses Capital's capabilities with regard to integration to third-party systems such as MCAD and PLM. All of this was built with three core principles in mind. Data coherency ensures that all domains work with correct, synchronized, and managed data. Capital was built to integrate so that data coherency extends beyond just Capital but into adjacent processes. And advanced automation of complex tasks create better designs faster. These principles deliver the world's most powerful electrical systems engineering tools, which are quite different from traditional drawing-based tools. This paradigm shift has attracted real executive attention. One commented, "I'm not buying new electrical tools just to solve my wiring issues, but what it can do for big challenges in systems engineering and across the broader enterprise." The integrations of Capital are particularly sophisticated when you consider MCAD offerings such as NX, which offer real-time collaborations between the mechanical and electrical engineers. Tight integrations with PLM systems, such as Teamcenter, provide expanded data flow and workflow orchestration, all from the same engineering environment. One key example of advanced automation is how input models are transformed through generative processes to produce deterministic outputs. This is done in every domain. Functional designs are automatically transformed to logical designs, which are then transformed to physical designs, and so on. Your intellectual property, captured as rules, allows knowledge to be reused such that it controls the automation for your purposes. Capital was built for large enterprise deployments. This is done by ensuring that it's highly scalable, including its basic IT architecture. The integration technologies ensure that Capital works with an organization's IT infrastructure rather than against it. Project and workflow controls means organizations can control what data can be manipulated by whom and when. And significant security features are a must, especially for our customers needing to maintain strict access control to sensitive data. Capital isn't a theory. It's real, and it's in use around the globe by groundbreaking companies. Let's look at some benefits just a few have seen, such as these automotive examples. First, Tesla was able to solve production problems relating to electrical configuration variability and OEM supplier data exchange using Capital. Daimler Trucks has deployed Capital in Germany, Japan, Turkey, and the United States, demonstrating the product's enterprise scalability we just discussed. Here are two examples from the aerospace and defense sector. L3 Technologies, which produces flight simulators, cut the number of electrical change orders reaching manufacturing operations by 90%. This was attributed to the high level of data correctness delivered by Capital. This was achieved on L3's first Capital project, a Boeing 777 simulator. Pilatus, which builds small military and commercial aircraft, delivers electrical data authored by Capital into their Teamcenter environment. This is then available to other engineering domains to drive greater innovation via improved data visibility. These press releases and other success stories are available on our website, mentor.com. So let's summarize. Electronic systems intensity is driving extreme electrical complexity, which creates business-threatening costs, overruns, and program risks. These challenges can be addressed with model-based systems engineering tools that incorporate advanced technologies such as generative electrical design. The tools are part of a broad, integrated digital innovation platform that enables true systems-driven product development. In this lesson, we've described important industry challenges and how we address them through a digital twin. We've described Capital's core principles and how they make it a premier ECAD tool for modeling your digital twin. And lastly, you've seen examples from real companies.